Welcome guys to the best maths channel in Ghana and the world, and the best maths channel in Ghana and beyond. And this only channel is fierce when it comes to mathematics. Yes, we ended our section on logarithm involving equation, and we are going to talk about another examinable area, which is a substitution involving logarithm. This is when the values of logarithm are given to you in decimals, in letters, and so many expressions for you to solve. An example is maybe they're giving you that log 3. If log 3 is equal to a and log 2 is equal to b, yes, maybe solve a given expression that find maybe log 3 plus log 2, for which you know this expression, since they are adding, they are going to multiply. Yes, so in replacing the letters, you are going to have log a times b. For this, when you separate them, log a plus log b, because of the values they have given you. This is an example. So in this substitution, they will be given values of the given log we are going to work with. So this aspect too, they are past questions I've selected, and we are going to look at them one after the other. So without wasting much time on this, we are going to quickly solve our first question involving this. So our first question on the screen, they say if log 2 is equal to a and log 3 is equal to b. So we are to find log 12. We are to find log 12. And to find log 12, can we expand it so that we can get an expression in terms of 2 and 3s? That's the question we should ask ourselves. Yes, and we can do that. So what I'm asking we can do, we can expand this as log 4 times log 3. Log 4 times log 3. Yes, and I can express this one in 2s. So this should be a yardstick for me. Now I've gotten this, so now I have to get something relating to this so that I can easily solve. And this one can give me log 2 raised to the power 2. Yes, log 2 raised to the power 2. And since these are multiplying, then add log 3. Yes, log 3. Log 3. So this is what I've gotten. Now I can express this one as log 2 plus log 3. Now I've expressed this in 2s and this in a's. Yes, this in 2s. And they have given me log 2 as a and log 3 as what? B. So I have to just put in the values here. So this one means 2 multiply the value here, then plus what? The b. Yes, plus the b. So 2 times a will give me 2a, then plus b. So this is the final answer we are going to get. This is the final answer. So when it talks about substitution of logarithm, this is something that we are going to have. So we are quickly taking our next question. So this question says, given that log 2 is equal to 0.3010, we should find without tables or calculators I log 8 and II log 80. Yes, log 80. And we know this value is a correct value. When you press log 2 on the calculator, you get this answer. So the trick here is, I've told you, can we express the 8 in 2s? Is yes. So we can have log 2 raised to the power 3. 2 to 4, 4 to 8. And for which this is the same as 3 log 2, which means the 3 is going to multiply the value of 2 that they have given you, 0.3010. And this one, with the help of our calculator, when we multiply, we are going to get 0.9030. Depending if they say 1 decimal place, 2 decimal place, you leave it. So I'm going to leave my answer in this form. So this is the value. So the substitution of logarithm, this is how it is. Yes, and we are going to use the same principle for the log 80 as well. They've given us log 2. So now the log 80, can we express it and get something like log 2 inside? The answer is yes. So we can have log 8 times log 10. Yes, log 8 times log 10, for which I can express this one to as log 2 raised to the power 3. They are multiplying. So log 10. So I'll have 3 log 2 plus log 10. Follow closely. So this will multiply the log 2 value they have given us, 0.3010 plus 1. Certain things when you are solving mathematics, nobody should prompt you or tell you. You should know. Yes, we are simplifying. I've told you the log to the base of itself is 1. And a log without a base is in base 10. So when you get the 10, quickly change it to 1. Yes, so this will give us 0.9030 plus 1. So our final answer, when you add, you're going to get 1.9030. So this is the answer. So in the substitution, the value that they are going to give you, make sure you express the logarithm question in terms of the answers or the values they are giving you. So if it is the log of 3, log of 7, and the rest, make sure you express them to get the 7 and the 3 and the 5 they are asking you to do. Normally, if they are even numbers, we normally expand them. So normally they give you the value. This is how we simplify these questions. So we are going to take another question involving the substitution. So given that, the next question is given that log base 3/5 is equal to 1.465. 1.465. We have to evaluate without tables log 325 plus log 315. Yes, plus log 315. Can we express any one of them in terms of the 5? This is easy to know. But what about when we come here? How are we going to expand it? So this one is going to give me log to the base 3/5 raised to the power 2 plus, now unless I expand this as log 3/5 times 3. Yes, so I've gotten 5 inside. So this one will give me log 3/5 plus, now let me separate this, log 3. So log 3/5 squared, then log 3/5 plus log to the base 3. This is the same as this, multiplication, addition. So this will give me 2 log 3/5. Yes. Then plus log 3, I'm repeating this, plus log 3. Yes. So now I have the 5. So 2 multiply the value of log 5. 1.465 plus 1.465 plus 1. Again, log 3 is 1. Now let's multiply this. Then we are. So this one will give me 2.93. Yes, 2.93. I'm leaving it in 2 decimal places. 2.93 plus 1.465 plus 1. For which when I add this one in 2 decimal places, or I'm going to get 5.395, and in 2 decimal places I'm going to get 5.4 as my answer. You get 5.4 as my answer. So normally, as I said earlier, the question given to you is a log 5. You can get 5 inside this. How do you get 5 unless you expand? So you have to be smart and know how to apply math. The easiest subject is constant practice that will let you know math. So and you have to be able to think fast. Yes, you should be able to think fast and apply whatever you learn. Yes. So normally in exams you'll be given these examples in class, and exam you see a different thing. The examiners normally want us to what? Apply, reason, if we can still use the same principle to solve a given problem. So people complain what they give in class is different from the examination. Yes, you have to apply, because if an examiner gives you in class 1 plus 1 and gives 1 plus 1 in the exams, that is not reasoning. Yes, it has to give maybe 10 plus 10 to see if you can apply the same addition principle to solve the given problem. So we are taking the next question on this. So this one, to if log 5 is equal to 0.6990, we are to solve log 25 raised to the power 1/3. Yes, log 25 raised to the power 1/3. Now we have to make sure that we get 5s inside this, and we can easily know that if you have followed the lesson closely. This one will give me log to the base 5 squared times 1 on 3. Yes, times 1 on 3. So if you follow closely, you understand, yes, how I got this. Yes, 1 on 3. And this one will give me log to the base 5, 2 times 1 on 3. It is multiplying. Yes, and we normally, a whole number with a fraction, we focus on the whole number. The whole number will multiply the numerator. So for which this one will give me 5 raised to the power 2 on 3. Yes, 5 raised to the power 2 on 3, for which this one will give me 2 on 3 times log 5. And since log 5 is given, so given as 0.6990, for which with the help of our calculator, 2 on 3 times 0.6990, we are going to get 0.4660, and to leave it in 2 decimal places, I'll get 0.47. Since this is a runnable, then this is a runnable number. So this is our final answer in terms of this. So we are taking the next question. So with this question, we have log to the base x3 is equal to 0.5283. Yes, and log to the base x7 is equal to 0.9358. We are to evaluate or solve I 27. Yes, the value of x of 27. So for which we know we definitely log 27. Yes, it's log 27. So since the base was given, so log x 27. And can we express this in any of these? Yes, we can express this 27 in threes. So this one will give us log base x 3 raised to the power 3. Yes, so 3 raised to the power 3 will give us 27. So this one will give us 3 log base x, then 3. Yes, 3 log x 3. Then we are going to multiply. Since they've given us log base x3, so 0.5283. Yes, so for which, with the help of our calculator, when you press 3 times 0.5283, we are going to get 1.5849. I'll leave my answer like this. If the question specifies either in 2 decimal significant, you should be able to leave it. So we are to the II. The II says we are to also evaluate root 7. This shouldn't be scary, so it means yes, log base x root 7. Yes, log base x root 7. Now we know we can eliminate the root, and this one will give us 7 raised to the power half. Yes, this is the same thing. The square root of any number is the power of half. Yes, half the index power half of the number, for which this can also be expressed as half log to the base x 7. So you see, this one we have gotten something like 7. So you know you are wrong if what you are solving, you've not been able to express the thing in either of the substituted values or the simplified values they have given you. So if you're able to get it, then you know that you are on course. So this means they are multiplying. So I have half now times 0.9358. Yes, for which, with the help of our calculator, when you press it, we are going to get 0.4679 as well for this value. So if you understand the principle, so you don't learn to forget, that's why you have to keep on practicing. So if you see the question, I have to apply this, I have to use this method to solve it. So this is a substitution method for you. So we are going to take the last past question on the substitution of logarithm. So with the I, we have if log x is 0.5 and log y is equal to 1.5. So we are to find x plus y. X plus y. So now follow closely. I'm going to solve this one after the other. So now this log x you see here is equal to 0.5. Now how do we make x stand alone here? Don't forget this has base 10. That was not brought. Yes. So you have to be smart and know a log without a base is base 10. Now if you have seen this, then this one will raise to the power this. So we are now going to get x is equal to 10 raised to the power 0.5. Now we've gotten our x. X is equal to 10 raised to the power 10.5. 0.5. 10 raised to the power 0.5. Now, the same as the log y. Our log y is 1.5. So, log to the base 10y is equal to 1.5. So now we are going to have y is equal to 10 raised to the power 1.5. Now we've gotten our y. We've gotten our x. Now they say we should what? We should add them. Yes, we should add them. So if we should add them, it is simply going to give us 10 raised to the power 0.5 plus 10 raised to the power 1.5. Yes, 1.5. So with the help of our calculator, 10 raised to the power 1.5 will give us 3.162. plus 10 raised to the power 1.5. So 10 raised to the power 0.5 will give us 3.162. Then 10 raised to the power 1.5. 10 raised to the power 1.5 is also giving us 31.62623. So we are going to add these two together, and in adding these two together, we are going to get 34.78 as our final answer when you add these two together. Yes, so let me run this in 2 decimal place. 785, so 2 decimal place. Then you add this, then you get it. So this is how we simplify this 1, 2 using the substitution involving logarithm. So we are going to take our very last question on this part. The last question, given that log 10 to 0.3010 and log 10(3) is 0.4771. We have to evaluate log 10 0.24. Yes, 0.24. Don't be scared. These can be expressed as 24 on 100. We change it as fraction, and this division can also give us log 10 24 minus log 10 what? 100. Yes, log 10 100. Now I can easily express this one in tens. Yes, but what about this one? If I express this one in tens, I'm going to get 10 raised to the power 2 here. Then this one, there should be something that can give me either 2 or 3. So this one, I'm going to use log 10 8 times 3 minus log 10 raised to the power 2 here. So this will give me log 2 raised to the power 3. Yes, log 2 raised to the power 3 plus log 10, sorry, do you have the log 10 3 minus this one will also give me 2 log 10 10. So you see, this one will give me 3 log 10 2. Now the 2 has come inside, plus my log 10 3. Then I have log 10 10. Yes, are you following closely? Yes, follow. Now these can give me 3. The 2 is giving us 0.3010 plus log 3, then 0.4771 minus 2 times what? 1, log 10 10. Now let's move forward step by step. So this one will give me 0.903 plus the 0.4771 minus 2, for which the final answer, if I add all these and subtract by this, I'm going to get negative 0.6199 as my final answer. Yes, as my final answer. So you see this simple question, you have to apply and get your right answer. Yes, and get your right answer. So this is the last question, and it's the past question as well on this substitution. So this brings us to the end of substitution involving logarithm. So logarithm involving substitution. Don't forget to subscribe and follow us on Facebook, on TikTok, and recommend to all students to have a benefit as well. And if you follow this channel, your ace in mathematics is assured. So watch out for another part on logarithm, which will be the change of base. The change of base, which is another tricky area and examinable area. So to meet again, we say goodbye for now.